In this video, I'm going over the Newton-Raphson method, in particular, finding a root to 4 decimal places. We're given the Newton-Raphson formula, which is xn plus 1 equals xn minus f of xn divided by f prime of xn. All we need to do is substitute values into this formula. The question reads, use a Newton-Raphson method with a starting value of x0 equals 1 to find the root of f of x equals x cubed plus 2x minus 6. Give the answer correct to 4 decimal places. To start, I'm going to differentiate f of x. F of x is x cubed plus 2x minus 6. Differentiating that gives 3x plus 2. We're going to use that for every single iteration. Reminding myself what the Newton-Raphson formula is, xn plus 1 equals xn minus f of xn divided by f prime of xn. Now, if I wanted to find what x1 is, I would need to know what x0 is and substitute its value into the formula. So to find iteration 1, I'm going to use the starting value which was given in the question, x0 equals 1. I'm going to substitute 1 into the formula using the function I was given in the question. Using a calculator, I get 1.6. Iteration 2 is using x1 equals 1.6 back into the formula, and I get approximately 1.46612. I'm going to continue iterating until I get 2 consecutive values that agree to 4 decimal places. x3 is approximately 1.47500, x4 is approximately 1.4748, and x5 is approximately 1.4748. So I'm going to stop here. In summary, the answer to the question for the root of f of x equals x cubed plus 2x minus 6 is x equals 1.4748, correct to 4 decimal places.